Welcome to the Ty Beal Show, where we discuss food, science, and life. I'm Ty Beal, a scientist at the Global Alliance for Improved Nutrition, or GAIN. My guest today is Dr. Paige Stanley, a rangeland soil carbon scientist and agroecologist at Colorado State University. Dr. Stanley studies how grazing management can sequester carbon in soils to help mitigate climate change and build more resilient rangeland ecosystems. In our conversation, we discuss soil carbon and how it relates to climate, the role of cows in global warming, and how grazing management influences not just climate change, but water infiltration and biodiversity. A quick note before we start. This podcast is separate from my role at GAIN. Okay, let's dive in. Dr. Paige Stanley, welcome to the show.
Thanks so much for having me, Ty. I'm really looking forward to it.
So you are a rangeland soil carbon scientist and agroecologist. That's a mouthful. Can you tell us what that means?
Sure. In as much as I can, it's always hard to try and put a title on what I do because I feel a little bit like a jack of all trades, a little bit like a generalist. So it's kind of hard to describe. But pretty much what I do is try and understand how changes in grazing management can be used to help add more carbon into rangeland soils as a way both to mitigate climate change, but also to help create more resilient rangeland systems. And that's beneficial both to producers and land managers, but also to the broader public and society, all of us who rely on rangeland ecosystems to deliver ecosystem services that help us breathe cleaner air, produce healthier food, drink cleaner water, and rely on those ecosystems for other consumptive things like nature, wildlife, hiking, all the things that we love those rangelands for.
Okay. And so these rangelands, are these grasslands? Is that what you're kind of referring to, these ecosystems can you go into a little bit of detail there?
Yeah, rangelands are actually the broader umbrella term. Grasslands are a type of rangeland. This is a bit of semantics. So rangelands generally are all arid, semi-arid, temperate, what have you, systems that are generally grazed. Colloquially, we refer to grasslands more as more temperate grazed systems, so ones that are more covered in grass. Rangelands encompass grasslands, but generally we're talking about, I think, grazed ecosystems. The only different kind of landscape would be more like a pasture, which is something more like a managed ecosystem that's seeded into something that's not its native vegetation.
Okay. All right. Sounds good. So Let's dig into the soil details here. Can you explain a little bit about how soil carbon relates to carbon in the atmosphere?
Sure. Well, they are a lot of one and the same. They're just temporarily in a different space. So carbon is it's an atom that you can find on the periodic table of elements, but it's the component that makes all living things on Earth what we call organic. And so it's the building block of all kinds of things living on Earth. And it lives in a bunch of different places and what we call pools on Earth. So the ocean is actually the largest pool of carbon on Earth. But then there are other kinds of pools and terrestrial pools, and soils are actually the largest terrestrial pool of carbon. So soils hold more carbon than even the atmosphere and all biomass, so all things like trees and grass and things like that on Earth combined.
So when most people think about, the forest is where all that carbon may be stored. But you're saying in the soil is actually vastly more. Do you have any numbers for the proportion of the carbon on land that is in the soil?
Oh, compared to just trees, I don't. I know it's about, this number might be outdated, so I don't want to misspeak, but I remember there being a paper some years ago now saying that it was about 3 times more soil carbon than all biomass on Earth. But biomass would then encompass, all things like grass and plants and including trees, but
and roots as well.
Well, well, some roots would be included in soil carbon. But all of that to say is, soils hold a ton of carbon, a lot more carbon than I think people tend to consider. We think of carbon as being in these other places, right? It's bad when we think of it in the atmosphere. Some of it needs to be in the atmosphere to make, the kind of living tank that we have, but too much is very bad and contributes to what we know now as climate change, anthropogenic climate change.
Which is human caused for those who don't know that big word.
Right. Yeah. Human caused climate change. The things that we do as humans put more carbon in the atmosphere. So there's carbon in these pools, but then there are fluxes between these pools, some of which are natural. So for example, when plants die and decay, some of the carbon that was once living in the kind of biomass pool might then go into the soil pool. And then some of that carbon that's in the soil pool might get re-respired into the atmospheric pool. And so carbon is moving around these pools due to these fluxes all the time. And then humans can change where the carbon goes or the rate of these fluxes. And so soil carbon is one of these things that we can manage really directly by way of agriculture. In croplands, we influence the way or how much soil carbon is stored in cropland ecosystems by things like tilling, crop rotations. And in grazing systems or in rangeland system, which is the ecosystem that I study, our primary intervention here is grazing management. And the reason why that's so important is because grazing lands globally cover such a large swath of our total landscape. It's the largest total land user on Earth. And so the lever of opportunity covers so much land, and that's so much total soil carbon that gives us influence over, that it's a really exciting opportunity.
Okay, so maybe we can zoom out. So comparing different ecosystems in terms of which stores the most carbon. Do forests store more carbon in those ecosystems than rangelands? In terms of overall,
in their
global,
biomass or in their soils?
Overall, combined.
I'd need to probably look just to make sure I'm not misspeaking. I think all of these pools of carbon are great. And often I hear people like pitting these kind of ecosystems against one another, like, oh, the forest for the trees or whatever. And I'm like, well, yes, forests are great. It's ecosystems that are natively forested deserve to be natively forested. That's great. What I don't love is to hear that rangelands don't deserve to be rangelands, that we need to rewild them into forests, even when they might not have been forests. Because that's a better form of carbon. And so to take those animals off. And also there is a trade-off to these different kinds of carbon. So for example, carbon in forested ecosystems, above ground carbon is not as persistent of a form of carbon as is carbon underground. Now, mind you, I mentioned that carbon fluxes above ground and below ground all the time, and that is true. What is also true is that soil carbon tends to stick around for a lot longer than above ground carbon in a tree, for example. It's a lot less susceptible to something like burning down.
So it's more stable in the soil where it can maintain its presence over longer periods of time.
That's right. And that's always subject to things like, a change in management, or if you, for example, if you're in croplands, if you're to till it, it's not, you can't say with any degree of certainty that no matter what you do, it'll be there forever, but it's more likely to stay, for sure.
Okay. So I'm hearing you say that we really should not pit these ecosystems against each other. It's not a competition.
It's not.
It's really that each has their unique role. And what you're also saying is rangelands make up the largest if I heard you correctly, the largest land area of any type of ecosystem.
That's correct.
Yeah. So a lot of opportunity to manage those rangelands in ways that can optimize soil carbon. So can you tell us where do grazing animals fit into this? How do they influence this soil carbon?
Yeah, absolutely. So rangelands, one thing that they all have in common is that they are historically grazed, which means that these ecosystems have evolved being defoliated or being munched on by some kind of ruminant. Now, depending on where you are in the world, those ruminants may look very different. So, they might be antelope or elk in some ecosystems. They might be bison, for example, in the infamous Great Plains of the United States. They might be something else. But they all have evolved with native grazers over time. And that's very important because that kind of defoliation over time has created those ecosystems such that they are covered in grass to some extent. And that's what's made them such a soil carbon hotspot. Now, there are different kinds of rangelands depending on your climate, have different kinds of soil carbon stock. So, for example, arid and semi-arid rangelands obviously have lower soil carbon stocks than maybe a temperate rangeland might. But all that to say is that evolution with native grazers has created rangelands to be very, I don't necessarily want to say fertile because they're not fertile in the way that we think of croplands, but they're very important to global soil carbon stocks. And so when humans started to remove native ungulates, native ruminants from these ecosystems and replace them with domestic livestock, in the United States at least, this was done in such a way that it wasn't necessarily a one-to-one trade-off, where we were taking ruminants like bison and replacing them with a different kind of ruminant, which was cows or cattle, which do actually share a lot of common grazing traits if you manage them similar in the right way. But if you let domesticated cattle graze really extensively, they're actually quite lazy. Or if you overgraze these landscapes in the way that we did very historically, what happens is that you lose a lot of the soil carbon that was once there and that was created by those bison, which is exactly what happened. And so what was once, these landscapes with a ton of soil carbon, we were overgrazing. There's a lot of history there, but we lost about a third of the total soil carbon stock, at least in the United States, that was once there. That was a lot to do with overgrazing. It was also a little bit to do with other things like development, for example, or land use change from grasslands and rangelands into other types of land use, like plowing up of some of our prairies into things like croplands and things. But all of that to say is we lost a lot of the soil carbon that was once there in those landscapes. And so
just to pause you there, I want to go back just a little bit for people to hear. Maybe you can elaborate. What is it about rangelands and grazing animals that keeps them rangelands? What is it? The grazing itself that prevents the forest from growing and from trees from taking root?
Yes, in a lot of cases, yes. So in some cases it's grazing. In most cases it's a combination of grazing and climate. So a really good example is in places like California, where in some cases, like state or regional regulation has removed grazing animals from state or land trusts, and you can see woody encroachment to a large extent. And so without regular defoliation, what happens, and actually I myself and some of my colleagues published a paper last year that kind of sets up a framework to describe what we call undergrazing, which is that in a system that is a rangeland ecosystem, so it has a state in this ecosystem that can be a rangeland or a grassland ecosystem. Mm-hmm. When you undergraze, grass grows, it's not being defoliated, and so it lignifies, which means that the grass is it's setting seed, it's adding a lot of like woody or like structural components to itself, and then it's shading out any growth from happening underneath, and then it's preventing new growth from happening such that other things like shrubs and trees start to encroach rather than new, yummy, fresh grass year after year.
Mm-hmm. Okay. So when we think about maybe carbon or climate, you think plant a tree to help restore the carbon balance. What is the problem with, you call this woody encroachment, what is the problem with trees starting to grow in areas that have maybe been rangelands historically and prehistorically with grazers that have sort of kept these ecosystems in balance? What is the issue with that? Is that an issue, and why?
I'd say yes and no. To out my bias a little bit here, I love rangelands. These are the systems that I work in, but also it is a bit of a loss because there is a trade-off here, both in terms of the carbon and in terms of the type of landscape. In the same way that I would never say tear the trees down to make it a grassland, I would say don't just let the grassland or the rangeland become a forest because it can. If that landscape has been historically grazed and was a rangeland or a grassland at some point, I do think that we have a bit of an impetus upon us to try to maintain that to some extent. But from an ecological perspective, there is a couple of reasons why it's in our best interest to do that. One is that allowing that kind of woody biomass to accumulate is a fire hazard in a lot of places where that kind of woody encroachment happens. So that's especially true in places like California, Texas, Colorado, Utah. Preventing defoliation like that is a fire hazard. And Native Americans, for example, when bison were really prevalent as the native ungulate in these kinds of regions, would do a bit of both. They would both manage grazing in terms of, bison herding, and burn to prevent huge fires like the ones that we're seeing become larger and more common now. There's also a bit of a soil carbon trade-off. When you have fewer grasses and more woody biomass encroachment, roots from grasses tend to store more soil carbon underground and less carbon above ground. So you're shifting more of the carbon to be above the surface, which is more prone to loss from things like fire, and you're shifting it from below ground to above ground. So on its face, that wouldn't be a problem if those ecosystems weren't also more prone to burn, but because they are, the shift from below to above ground also makes it more prone to loss, which means that it's more susceptible to being put back in the atmosphere.
Fascinating. So I think that will be illuminating to a lot of people. There is probably a narrative out there that the more trees, the better. Doesn't really matter.
Sure.
Right? And so I think what you're saying is, no, trees are great. There's a place for trees. And also grasslands are great. Rangelands are great. There's a place for grass. If the grass stores more of the carbon below ground in these landscapes or these ecosystems that are prone to fire, right? They evolved with fire. Having more trees actually makes it more susceptible to losing more carbon. So I think that's really fascinating for people to hear. Let's go into a bit more about how to manage grazing livestock, because you talked about that. Yeah.
Can I add one more comment there? Is that there are also plenty of examples where it's not a black and white example of grass or trees. That is such a false dichotomy too. Like, for example, oak savannas in Spain, in Northern California. Like, imagine all these ecosystems where grasses and trees exist in complete harmony. Yeah. And actually there are really famous grazing ecosystems in where that's true. And so I don't even see these as like antagonistic ideas. You just have to get creative in how we think about them. And like in these entirely environmental spaces that we inhabit, it's like just a funny conversation that I see happening often. And I'm just like, get me back out in the field where like I don't have to think in this black and white anymore.
It doesn't need to be all or nothing.
It doesn't.
It's a continuum. Okay.
It really doesn't.
So, okay. So grazing livestock. Now you've said that there are ways to manage these grazing livestock that can help store the most carbon. Can you talk a bit about that in detail? What do we do? Like you said, there's overgrazing, there's undergrazing. How do you do grazing the right way?
Question of the, I don't know, last 100 years maybe. Scientists have been trying to answer this for literally 100 years, and from a bunch of different perspectives. There isn't a singular right answer, which I think infuriates everyone. But I actually think it is the only right answer to say that it depends, because if you think about the variety of types of ecosystems that are encompassed by the term rangelands, for example. When I say rangelands, I'm talking about the short grass steppe of northern Colorado. I'm talking about tall grass prairie. I'm talking about the oak savannas of northern California. All of these are rangelands, and so to say, how do we graze the right way? The answer to that question would be different in each of those ecosystems. And the answer would also be differently depending on if you were asking, graze the right way for what? For sage grouse, for soil carbon, for an endangered species of some other variety, for a single perennial that you're trying to bring back for, so there are different goals that land managers, environmentalists, that folks have.
There's no one size fits all approach.
That's right. I will say that I do think that in general, most production and environmental goals are aligned in rangeland and grazing ecosystems. I think way more than people give it credit for, because soil carbon drives most things in grazing systems, things like productivity, water holding capacity, what have you. To say that optimizing grazing for soil carbon would be to say that it is optimizing for most other things, I do think that would be generally true. Okay. But like the individual strategies will vary quite a lot. But there are like some broad stroke things that I think make sense across all of these ecosystems. And the one thing that I say is like adaptivity and decision making is the one throughput. And so this is where I feel like, holistic planned grazing, adaptive multi-paddock grazing, these kinds of frou-frou terminologies in the holistic or regenerative grazing space actually do make a lot of sense. But people get very turned off by those kinds of terminologies when they first hear about them, because they're like, ugh, that doesn't, I want to know how to graze now. But it really is a shift in folks' mental models that is what it takes to be able to optimize grazing for something like a soil carbon outcome. Because it's not just like, rotating your animals every 3 days or 3 times a day even. It's knowing to rotate, for example, when they've reached 50% of the amount of grass that you want to see, or when you think that you're not going to get enough rain the next year and you want to save a little bit more residual. or you see a perennial grass coming up and you want to give it a little bit more time to set seed. So it's about like strategizing and adapting your decision making to optimize the types of things in your ecosystem that drive things like soil carbon. That's the kind of decision making framework that I think really makes a difference, and not just like a pinpoint thing like a rotation schedule.
Okay, so what is the ecosystem like? What are the goals? What are the priorities, right? Okay.
Yeah.
So that's a very complex or nuanced answer, right? You need to, it sounds like each person who manages rangelands and livestock and grazers really needs to take it a case by case based on their situation. Do you do any sort of how does it sort of work? Like, let's just say that you were a consultant and you're going on to some ranch or rangeland, and their goals are to, let's say, maximize sort of soil carbon, biodiversity, water infiltration, just sort of these general, ecosystem and productivity goals. Where would you start? How would you sort of assess that situation? Maybe if you give us an example in something where you've worked in, so maybe a particular type of ecosystem in California or Colorado or something.
Yeah, I think I'd first like to sit down and ask what they're doing, how they're grazing right then. So take a look at, it would be really lovely if they were using something like a pasture map. Not few producers utilize that kind of technology or platform. That's a pasture management technology where producers can log their rotations on an app or like an iPad or something. And it's a very visual way of showing how and when and how frequently they rotate their animals. In lieu of something like that, even like a chart, like a grazing chart. So I'd want to know something like how they decide when to move their animals, if they're moving them at all, how frequently that is and why, how they decide when to come back, how much hay or other inputs they're buying, how much money they're spending on those things. And then we can kind of work backwards. Because if, for example, they're saying like I move into this pasture on June 1st every year, and I'd be like, okay, why? Tell me a bit about why. Because I never want to approach a producer with like a I know best first, because the answer to that is always that I don't. There's always a reason for why they're doing what they're doing, even if I don't agree with that reason. But I think it's very important for me as a scientist to ensure that I'm meeting them where they're at, because I'm not a grazing management expert. They are that, but I can usually help them optimize their grazing management to meet the soil goals, which I am an expert at. So it's usually a bit about working together and finding the right language to meet in the middle.
Okay, recognizing the strengths of each participant.
Yeah, exactly.
You can bring your scientific background in soil and carbon, and they have their contextual experience. They've been grazing probably for many, many years.
Yeah, and then you usually want to start small. Like if they're managing, like out here in the West, I mean, I'm in Colorado, it's not uncommon for a producer to manage a 10,000, 20,000, 50,000 acre property. And so I feel that it would be very unwise to try and get a producer to just, try and adaptively manage, quote unquote, adaptively manage a property of that size in one fell swoop. So you might want to try and get them to think about managing a couple levers of their grazing adaptively on a smaller percentage of their acres. And I like to speak to ranchers in terms of individual components of their management. So even in the way that I study grazing, it's like, timing, frequency, intensity, duration. Like these are the grazing management levers that I think about in terms of how they manage and what to implement adaptively and why. So things like, and then there are other tools that they can use as catalysts to help them manage adaptively. So things like a pasture map, for example, there are technological catalysts, electric fencing, mobile electric fencing, for example. But it's really a decision-making framework, honestly.
Okay. Fascinating. Let's move into cows specifically, because cows get a bad rap for warming the atmosphere and contributing to climate change. Can you talk a little bit about how can cows be managed in a way that doesn't contribute to climate change, or that either, maybe that's the wrong question. How do you sort of optimize management of cows? What is the role of cows in climate change? This type of this thing here, because I think a lot of people who care about the environment are trying to understand, well, should I eat beef? How much should I eat? Right? Does it matter if I've, what type of beef I'm eating? Should I buy it from a regenerative type of ranch? Right?
Yeah. Oh, such a huge question. Oh, I mean, that's how I got started, is thinking about that, essentially. I think we don't yet have a clear answer on to what extent even something like regenerative grazing can or does negate the role of an animal in its contribution to climate change. And I'll qualify that entirely, because I don't want to cause anybody like a pure panic spiral. Cattle emit methane. Methane is a potent contributor to greenhouse gas emissions and climate change. That is just the truth. There's no way around that. Methane is a natural part of greenhouse gas cycling to an extent. There are and should be better ways to account for its actual warming potential in the atmosphere. All of these things are true. Cattle and their emissions and the beef sector's emissions, I do believe, have been over-vilified in the total agricultural contribution to climate change emissions and climate forcing to an extent, especially on the grazing side, in my personal opinion. It's also true that if we think about breaking apart beef's total greenhouse gas footprint in terms of the supply chain first, most of the emissions would come from the cow-calf sector. So beef, we can split into three parts of the kind of supply chain: cow-calf, stock rearing, and feedlot. Cow-calf is most of the time that the animal is alive, and that's also where most of the grazing takes place. The last kind of third of the animal's life is split between the other two parts, where it's spent being fed something like grains and gaining weight to be sent to market. Mm-hmm. That section of the supply chain actually doesn't account for the majority of the greenhouse gas emissions, because most of the methane is emitted during cow-calf. So it's a bit of a misnomer when we think about what is the most, quote unquote, natural. It is the cow-calf, but it is the largest contributor to the total warming part of the footprint. It is also true that in terms of fossil fuel based contributions, that is coming from the latter section, the feedlot and backgrounding or stock rearing. So you see how there's a little bit of pull and tug depending on how you want to slice and dice the greenhouse gas emissions. Mm-hmm. I focus on the grazing side. So when we think about sourcing and even ways of grazing that can help mitigate the greenhouse gas emissions that are produced in that portion of the beef supply chain. So, animals, depending on how you graze, kind of back to the soil carbon piece, they can be grazed in such a way that can pull, that can change the way the plants grow in ways that pull carbon dioxide out of the atmosphere and into soils at a larger rate. That is true. And yet there are very few studies, actually very, very few, that have measured soil carbon over time. So we don't have a good idea of how much soil carbon that really is, even though we know it can and does happen. I conducted a study during my master's. That was a 5-year study. We actually have a 10-year update to that paper coming online. And it turns out that when you do drive soil carbon sequestration via adaptive grazing management, or however you want to manage your grazing in ways that do drive soil carbon accrual, it turns out to be a really powerful lever of greenhouse gas mitigation, meaning that when we think of all the opportunities to mitigate greenhouse gas emissions for cattle and grazing, however, feeding them seaweed or vaccines or changing their diets, soil carbon via changes in grazing management swamps most of those opportunities. It's mitigating more. But we have very few data. So I think potent opportunity, we need more data to put some bounds on the uncertainty there.
So we need more people like you doing the work that you do to figure out how do we really demonstrate this scientifically. So
That's
a lot of potential. I think maybe a disappointing answer that we can't really know to what extent these approaches can really impact at a scale. I'm really curious about something. In the Great Plains of North America, and this is sort of the case in any, what you would say, maybe wild rangeland, there are native grazing animals. And so, historically, at some point, there were probably in the millions, tens of millions bison, right? We don't maybe know exactly how many, but a lot.
A lot.
Now, what are those emissions from those bison, and how does that compare to our domesticated livestock like cattle? And is there some sort of argument that if the natural land can support a large amount of grazing ruminants, could there be a way to sort of emulate that approach if done in the right way with a domesticated ruminant like cattle?
Yes. Okay, to round out my last point really quick on the soil carbon piece, there's so many things in the works in terms of papers coming out. Like, we're measuring these things over time. We don't have those data endpoints quite yet. So just know that we're working on it. Yeah, stay tuned. In the next 2 to 3 years, there is going to be an influx of papers. We will have a better answer soon.
Okay. Good.
Okay. In terms of, so this is something I've been asking myself, and others have been asking themselves too. Like, we were once able to support such a large herd of ruminants, even domestically. Could we do something similar? And how does that stack up in terms of not only protein production, but also greenhouse gas emissions? Does that about sum it up?
Yeah.
So 2 things. There was a handful of papers that came out between 2015 to 2017 that were termed livestock on leftovers, attempting to answer that question, at least in terms of like protein production and greenhouse gas emissions.
And leftovers just meaning like crop residues, distiller grains.
That's right.
Things that are not sort of consumed by humans.
Yes. So they were attempting to ask the question of like, if we were just to try and produce protein from ruminants in grass-based systems, and then from like leftovers from the crop production system, how much protein consumption could that support? And it turned out to be not that much. And that's because we are only able to produce as much protein domestically as we do now because it's supported by about 30% of the total crop production that we produce from corn and soy, for example.
Feed crops for livestock.
That's correct. Yeah. So it turns out to be a trickier question to answer than I think we thought, because a lot of our livestock production is kind of artificially supported by our cropland production system. So we're only I don't even want to say as efficient. We're only as productive as we are because we've created the system to be that way. So I don't actually know how much we could support in a system like that. We also export quite a lot of beef. I don't know, the system bounds, the kind of planetary bounds of the way that we produce beef is so different now that I have a hard time even wrapping my mind around that.
So it's really hard to know how much beef, for example, could somebody reasonably eat, per person, everyone in the US, for example, or globally. And I think that answer, it kind of makes me think we've seen some pretty prescriptive guidance about how much to consume to stay within planetary boundaries, for example.
Yeah.
And maybe those are sort of based on quite a bit of speculation and uncertainty. And so it's not to say we should have as much as we want, but it's sort of to say, look, the jury's still out. We don't really know with a lot of confidence exactly how much beef and other products can be produced in a sustainable way, or what the impact would be if the practices were changed at scale. What about if consumers are at least trying to say, well, I like beef, but I want to try to eat in, an ethical way, something that has the lowest impact or lowest negative impact on the environment. We see more producers in the market with products that say regenerative, right, or grass-fed. Does that have an impact? Maybe on average, I know there's probably a lot of variation, but is it better to have the grass-fed beef burger than the grain-fed? Is it better to have the regenerative produced one?
In terms of health, planet, soil?
I'm thinking in terms of climate.
I would say if you are gauging better from the climate's perspective, just from the label, it would be pretty impossible to tell, because labels are such an impossible space to navigate in my personal perspective right now. From my personal perspective, the labeling landscape in food, at least domestically right now, is a little bit like white noise. Every additional label I see, I would say most consumers wouldn't be able to tell you exactly what all natural means, what organic means, what pasture raised means. And so to expect them then to know the difference between a grass-fed, grass-finished, which are different from the USDA's perspective, feels like even more. And so then to put the impetus on the market for then the consumer to be able to expect them to know the difference, and then beyond that, to be able to put their dollar and willingness to pay on that difference, just feels a little bit silly to me, honestly, because people have other felt needs that they need to worry about first. Cost, nutrition, you know this better than I do. Like, willingness to pay studies are so incredibly problematic and nuanced. Like, people have other things that they need to worry about on a day-to-day basis. To expect them to drive the difference in a market-based way from a grass-fed label feels iffy to me.
So we're a long way off from having a labeling system that really can make it simple for consumers who care about the environment to choose the product that is lower in negative impact. How about in terms of the solution? Do you see this more as a whole systematic issue or systemic issue where we need to just across the board incentivize more sustainable type of practices? Is that where it comes into? Because what you're saying, I think I really resonate with. When most people are going to the store, where money is tight, time is tight, they're not going to be able to understand all of the differences between things. I have trouble even working in this area knowing what the difference is. So we can't necessarily expect it to be all on them. And those who could make a choice, who have enough purchasing power, they're probably a smaller, a minority, right? So they're not going to have the biggest impact. So what is it that can be done to move the needle in the right direction?
Oh yeah, that's a great question. I can see so many creative solutions. One creative one, and then I'll get to the one that I actually think will be the most impactful, is all throughout grad school, I was a recipient of SNAP benefits. And so one thing that California did very well, at least in the Bay Area, was they subsidized SNAP benefits and offered like an extra, I forget how much it was, like bang for your buck to take your SNAP benefits to the farmer's market. And so it was a really interesting, I think, opportunity, number one, to get to know more about your food. I obviously work in the food space, but for somebody that's not me, to get to know a little bit more about your food and also to meet farmers and ranchers. And so it's like a three-legged, I think, benefit situation where it's education, I'd like to hope that this is true, but for the folks at the farmers market where I was shopping, I know it was true. Regenerative farmers and ranchers selling their product. So it's like an actual market to consumer, direct pipeline. Mm-hmm. And it's a way to mitigate that situation that you were just describing, which is exactly right. Folks who are in the upper echelon of consumptive power being the only ones that can afford to pay for things like, environmental, whatever, or organic, or whatever label that they're willing to put their money to. So it was one of those like really creative solutions that I thought worked really well. And it had nothing to do with labels at the end of the day. It was just a creative workaround.
Yeah, that's awesome.
Yeah. The solution that I tend to put a lot more like gumption behind is a policy oriented one. There are other market-based things that I do think might have some merit that we can talk more about later, like carbon markets. I think in a, if everything aligns and it works well, I think they actually could drive some change. But I am a policy wonk at heart, and so I tend to hold a lot of weight. I want to hold the policy's feet to the fire on a lot of these things. And so I honestly feel like if we want regenerative ag to work, which I think as a collective we do, it's not going to work if it's not going to make money. And right now there are real barriers that have really nothing to do except policies getting in the way. For example, things like crop insurance, creating an artificial prop for practices that have negative environmental consequences. And that is an artificial prop for very cheap food, which then creates a negative feedback loop. Cheap food, high consumption, ultra processed food, obesity. So the loop goes round and round and round.
So you're saying like incentivizing the right things, because right now producers aren't being incentivized in any sort of optimal way to produce foods in a sustainable way, because there's a lot of, I think, structural issues that have historically been implemented that are not really aligned with the values of trying to produce things in really beneficial ways to the environment.
Totally. Or at least get out of the way of, or at least policy can get out of the way of trying to do the right thing and not subsidize the wrong thing.
So making it easier to do the right thing.
Yeah. And I mean, there are some inherent challenges, right? Like fruits and vegetables will always be inherently more expensive than grains, for example, because they're fresh, they have a shorter shelf life. You have to refrigerate them. Grains are more shelf stable, so, but there are many buts here. Like, you don't have to put a penalty on a crop rotation, for example, or you could at least think about creative ways to lower insurance for producers if they are demonstrating, improved water holding capacity, so improved drought tolerance on a regenerative grazing system. You see what I mean? Like, there's so many opportunities here that we aren't taking advantage of, and are, in fact, I think, disincentivizing.
A lot of work to be done. It's intimidating. I'm really glad you're doing that work. It's intimidating because it feels hard to make policy changes, and they're absolutely needed. So more power to you. You have mentioned other, what you call ecosystem functions, and these, go beyond soil carbon and things like water, either carrying capacity or infiltration, biodiversity. Can you tell us a little bit about you said there's actually, encouragingly, a lot of synergies where if you focus on one ecosystem function, there's often win-wins. Maybe not always the case, but how does the grazing system and how does livestock and maybe cows in particular, how do they fit into water use, biodiversity, these other ecosystem functions?
Yeah, so I'll answer the first pillar of the question first. Like, how does carbon maybe drive or fit into these other ecosystem functions? And then what is the role of cattle and rangelands in driving all of these things together? I think right now we're seeing a shift from a carbon focus to something a little less carbon focused, and that's, I think, come from an administrative change, but I'm actually digging my heels in a bit on the carbon focus because carbon is the driver of many of the ecosystem functions. So soil carbon is the thing that creates the stickiness in the soil, that holds onto the water, that cycles the nutrients, that creates the houses for the soil microbes, that prevents soil from eroding. Soils aren't able to do those functions if they're just inert. And so I'm happy to speak about soils in a way that meets people where they are. If that's soil health, that's totally fine. What I'm a lot less happy to do is take carbon out of the equation, because it's not the bad guy. It's important that we measure it, that we understand it, that we optimize it, that we manage soils to add more of it, because the problem isn't going to go away. And so anyway, I just felt the need to say that. So in rangeland ecosystems, let's see. So depending on how you graze, you can, I think I mentioned earlier, kind of lose or add or not impact your carbon at all. And really, all of that is indirect by way of what the cows are doing to the plants, really.
Okay.
And all of that will trickle out into other impacts on things like water. So soil water holding capacity or water infiltration is a really good example. So all else equal, soils that hold more carbon can infiltrate more water, which means that if you have a major rainfall event, you're able to absorb more of the water from that rainfall event than have it leach out, for example. And that's really important because if the rain is going to fall in a rangeland ecosystem, which are more typically drought impacted than anything else, you want to be able to hang on to it, because that's what you need to grow the grass, to feed the animals, to circulate the carbon. Like, that is the driver of all the things.
Yeah, it's so important. You don't want it to all run off into the ocean and you lose all of the fresh water that's so critical to the ecosystem.
Yeah, that's right. And then it creates a bit of a positive feedback loop, right? You have a little bit more carbon, you hold a little bit more water from the next rainfall event, you grow a little bit more grass, you store a little bit more carbon, you hold a little bit more water, you grow a little bit more grass. So it feeds off each other.
So where do grazing animals fit into this? Is it like the way that they're grazed can sort of make more carbon stored underground, increase plant growth, or it could be, if it's mismanaged, it can sort of take away from the carbon stores? And is it either, it can do either of those things depending on how it's managed?
It can do either, both, all of those things all at once, really.
Okay.
So animals, when they graze, pretty much what they're doing is they're biting off. Well, actually, what they're doing is they're wrapping their tongue around the grass and pulling. What they're doing is they're removing some of the plant or the carbon from the top. Grasses, when they're grazed, and it depends on how much of their biomass is removed, it determines their response. And it's the response over time that drives the carbon response underground. And that's where the interesting stuff starts to happen. So for example, if grazing animals, for example, if there's too many of them, or they spend too much time grazing a single pasture, or if they take off too much of the plant, they graze it clear down to the dirt, that plant and all the roots underground, they're going to be like, okay, well, we don't have enough above ground green leafy biomass to regrow, so we're going to let all of our roots die now. And then that plant doesn't grow back, the roots die, some of that soil carbon's lost, the microbes that were feeding off the roots don't have anything yummy to exchange anymore. And so all of that once like really functioning barter trade system is lost. If, for example, a land manager, for example, during the growing season, there's plenty of grass. They come through with their herd of cattle. They take a little bit off. They rotate them off, and the plants they've taken a hit. They've had some of their biomass removed, and they say, oh no, we need to immediately regrow. What they'll do is they'll allocate some of their carbon to their roots below ground, and they'll allocate some of it above ground. So it's a bit of an exchange. And so they'll do a little bit of both, which is, that's what we want, because it extends the growth a little bit. If instead no grazing happened, what the plant would do would just keep growing up and up and up, set seed eventually, and then no more growth happens. The roots senesce, the plant senesces, and there's no more like active growing happening. And then, you have more above ground biomass, but you have a lot less below ground biomass. So what grazing does is if you do it optimally, what I'm going to call optimally, is it gets you a good exchange of a little bit of a loss of the above ground biomass for what the cattle takes off and eats, in exchange for more below ground biomass and a little bit more above ground biomass for a little bit longer. So it's a little bit hard to think about, because I think when people often think about grazing, all they think about is the takeoff, the removal of the carbon. But really, carbon is a mass balance equation, where if you want to store more carbon underground, it's not just adding more of it, it's also about hanging on to more of it. And there are different ways to do that, and you can do that with cattle depending on how you graze them.
So is it sort of like exercise for a human, where you kind of break down your muscles a little bit and they regrow? I mean, is that sort of a concept? Like you're saying earlier, you said if these grasses are allowed to just grow to maturity, that actually may not optimize the carbon storage.
Yes.
So some grazing is important. Too much in the wrong way too much at one time can be harmful. It's really about being in balance.
That's exactly right. And that actually leads me to, I think, another point that I meant to come back and make earlier. That's an excellent point. The other thing is it's kind of like exercise for the microbes too. So if you just let these plants grow and grow and grow, you'll notice, like, for example, in the fall right now, if you go out for a hike, you'll notice the grasses are starting to turn brown. It's the end of the growing season. They're senescing. That'll happen a little bit sooner, especially in rangeland systems if they're not being grazed. And so if you just let that happen for years and years and years in a rangeland ecosystem, and you've taken all of your defoliators off, you're just accumulating that kind of crunchy, sticky, what we call lignified or like structural plant material above ground. Mm-hmm. That's not very yummy to the microbes that live in the soil. And so it's harder for them to break down those kinds of plants. And that matters because, so what I just mentioned earlier about like, it's also about how much carbon you retain in the soil, not just about adding more, but about like retaining more. Mm-hmm. Once plants turn into litter on top of the soil, then it's a function of like how quickly do they break down, how much of it is accessible to the soil microbes, for example, how much of it is roots versus things like plant litter or things that roots exchange with the soil. Things that are very tough like that are very hard for microbes to break down, and so they form a type of soil carbon that doesn't tend to stick around for very long. So it's not the kind of soil carbon that stays for a very long time. And so it tends to get re-respired back into the atmosphere more quickly.
So this is really fascinating to me. I think what you're sort of highlighting is that there is this sort of synergy in sort of optimizing soil carbon with a lot of other ecosystem functions. It really can be a lot of win-win when you put things in balance. So really maximizing the ability of the land to absorb the water that falls on it, maximizing the microbes and the biodiversity in the soil, which I assume, you can correct me if I'm wrong, a well-functioning grassland, rangeland, below ground, above ground, that's probably going to facilitate more biodiversity in the ecosystem itself above ground. Is that true too? Like if you have a well-functioning grassland, or if you overgraze it and it all dies,
that's true.
What animals are going to be able to live there?
It's true. Biodiversity is a tricky one. It's a little bit of a chicken and an egg situation. Like, is it the above ground biodiversity that fosters the below ground biodiversity, or is it vice versa? That one's tricky, but in general, yes.
In general, though, if you're doing things in a way you're managing the grazing in a way that really helps with carbon and
yes,
water holding and microbes underground, that probably will be benefiting overall biodiversity. Is that
correct.
Right?
Yeah.
Okay. So that's at least good to hear. Like there's not in this, at least in this space that we're talking about right now, there's not these, trade-offs of like, well, if you want to affect climate change, you got to like kill all the animals and plants and the microbes to do it, right? It's not really like that. You're saying there's actually a more positive message here. We can do a lot of positive ecosystem functions by approaching things in this sort of holistic way.
That's right. And the other thing too is grazing animals, again, like optimized for a soil carbon and an ecosystem response, they kind of upcycle the grass. So by like grazing a little bit can also transform it into a really powerful thing, which is manure. So by taking off some of that like cellulotic, lignified kind of crunchy stuff, putting it through their back end, turn it into something that is very accessible and yummy to soil microbes, who can then turn it into the kind of soil carbon that does stick around for a very long time. So, and that's not something that's like easily understood or accessible knowledge by the public, which is totally understandable, but that is true. Like in a grazing world, manure deposition is a really powerful way to build soil carbon, but only when managed correctly, because we're not talking about the kind of manure that's in a slurry, in a lagoon, in a dairy. Like, this is not it. We're talking about manure out on native range, which is a very different way to build soil carbon than we're talking about otherwise.
So it really sounds like with a lot of these questions, the answer is it depends, right? Like with manure, it can be used to facilitate biodiversity, and it can be used to harm that or produce emissions or runoff. We didn't really talk about eutrophication, things like that, right? So there are a lot of I think nuances to these questions, and I think that's really important. Now, a lot of people will still be just wanting to know, should I eat less beef? Should I eat beef? Your perspective, you have a chance here as the final sort of question is, do you think that that's an important thing for people to think about? Should we be thinking about, if we care about the environment, how much beef are we eating? Or is that the wrong question to be asking?
I've changed the way I've thought about this at least 3 times in my life since I've began thinking about these questions. I've landed most recently from a more global perspective. Like, if we were to calculate how much food we should eat on an individual basis from a planetary boundary, like, protein per person, or emissions per pound of carcass weight, like, how much does that come down to? Am I allocated on an individual basis? Is kind of where I was maybe 8-9 years ago. Where I'm at now is very different. It's more of like I value these things, and these are fostering really adaptive, resilient rangeland systems that we need to buffer the things that are happening and that are yet to come. More intense droughts and floods and biodiversity reservoirs and, all the things. And yet we need them to be helping mitigate climate change. So will I be purchasing beef from those systems? Yes. How much beef? I'm not here to tell anybody. And also, I eat it when it feels right. I don't calculate my beef consumption, or I don't allot myself however many grams per week per whatever, according to the most recent eLancet. I think about my consumption on a much more local and regional, kind of neighborly way now. And I'm not saying that everybody should do that. That's the way I do it now. I try to source from places that I know and am familiar with, from folks who use practices that I'm deeply familiar with on ranches that I've been to, that I've walked. And I'm not like a, source locally, vote with your fork. That's not what I'm saying, because actually transportation is like a drop in the bucket in terms of emissions, especially for beef. Like, it matters almost not. It's just that it matters to me to know that if I'm going to be eating it, that it's come from a place that is embodying the types of things that matter to me.
Right. Okay. So big takeaway is maybe talk to your local rancher, go to the farmer's market. You don't have to get local, but if you are more familiar with how these things are produced, you can have more confidence that they're produced in a way that aligns with your values.
That's
and also, you're not trying to be prescriptive. There's these global numbers per person that have been thrown out, and you're saying it really depends on where you are. Don't really think with that mindset, because it's all about the context. I think that's refreshing to hear, and a lot of people will probably appreciate that. So, Dr. Paige Stanley, thank you so much for joining me today.
Yeah, thanks so much, Ty. This has been so fun.
Awesome. All right, take care.
Yeah.